In this video, we are going to add some level elements that the character can collide with so that we can test the player's movement. Let's get started. So in the game scene, we had the character mesh and a camera. If you are missing the camera, you can add it. So player, camera. And now we need some ground for the character to collide with. To do so, select the game node and add a mesh instance. This is the base node to add a 3D mesh to your scene. You can create a mesh procedurally by clicking on the mesh slot in the inspector, and we're going to create a new plane mesh. I'm going to make it 50 by 50 units, and that is it. Now, that mesh by itself is not going to stop the character. This is just a visual element, and we need to create collision boxes for the character to collide with it. There are two ways to do so. One is to go to the mesh menu and to create a Trimish static body. It's going to automatically create some collision polygons based on the mesh's structure. Another way, more manual, that we're going to use right now, is to go to mesh instance. We're going to add a static body node. So it's a physics body that is not going to move in the game. It's just going to collide and stop other elements of the game, like the character. Then that physics body, we are going to add a collision shape to it, because by itself, it needs a shape to know how it can detect collisions. And so in the shape slot in the inspector, we're not going to create a plane shape, but we're going to create a box shape. Box is the most basic type of collider that you can use in your games. It's really convenient. Click on the box shape resource to expand it. And for the extents, we're going to enter 25 on the x-axis and 25 on the z-axis. That's because the extents are relative to the center of our box here. So the actual length and width of our box is twice the extents. Then the extents of 1 on the z-axis makes it 2 units tall or height, and we need to move it down to align with our plane there. So control click on the y-axis and move down 1 step or 1 unit, and that should align perfectly with the floor for now. Then just note that I've set the world in the game to be on the second physics layer. So the player itself is going to be on collision layer number 1, and it's masking layer 1. We have to change that. So go to the player scene, select the player, and it's going to mask layer 2. The idea with that is that we are going to separate the elements that move in the world from the game world itself. Using physics layers like this is also going to help optimize your game, as Godot will only check the layers and masks that are matching with one another and ignore the rest. So, going back to our game scene, on the static body, I'm going to set the collision layer under the physics body category to 2 and remove the mask. Mask means this object, our plane here, and static body, detects objects in the world by itself. We don't need the ground or other elements that are not interactive to do any of that. So this is a general good practice, removing masks from objects that don't need it. Then we have a pre-made object called playground in the source directory, level subdirectory, that you can drag and drop on the game directly. It's going to be added to as a child of the node you had selected. So I'm going to reparent the node by clicking and dragging to make it away or outside the mesh instance there. Select the playground, and then I'm going to reset its translation to 0, like so. Then we're going to rotate it 90 degrees, and I'm going to move it away from the player so that it's behind the camera. At this point, you can try the game and see your character moving on the floor. So right now, Manakini, in my case, is turned 180 degrees compared to the player. I'm going to go back to it and rotate it along the y-axis, 180 degrees, so that it aligns with Godot's axes. This is part, I hope, of something I mentioned, that the convention for axes is different in pretty much every game engine and tool. Now, I'm going to move the camera back. So for that, Control 2 is going to split the viewports in two. I'll select the camera and set it to preview in the viewport in one of the two views, and move the camera back up a bit so I can see the level a little better. From there, let's add some directional light to pimp up the level a little bit. I'm going to go back to only one view and not preview the camera. Move the directional light up, rotate it so it points down at the character, and I'm going to use the grain axis to turn it a bit. It's a bit hard to see on that light background. That's one area that could use some improvement in the future. But with that, so we have some lighting. We can go to the shadow category in the inspector to enable the shadows. The default ones will do for now, and we'll also add some environment to change the clear color and add a procedural sky. To do so, you need to use a world environment node, or at least I recommend that you do that. It's meant for that, so world environment. It's going to set the environment for that scene only. The environment being all the settings for the sky, the environment lighting, but also some effects like screen space, ambient occlusion, and things like these. Let's look for our environment. I have one called level environment.tres that you can use and that you can assign in the environment slot in the inspector. Note that the reason I'm not using the default environment is so that when you go to the player scene, you still have the gray clear color that makes it much easier to preview the character. The sky in there is also optimized to make your meshes readable by default when working in the editor, while the world environment inside of a level is going to set the tone and the visuals for that level in particular. I'm not going to detail the world environment in that course. You'll find a companion link to a free video I made on the channel that goes through the creation of an environment like this, if you're interested. But with that, that is it. We have our game. You can move the character and collide with the environment. There's one thing that we can do, optionally, if you want, make the camera follow the character. It's a small bonus for this one. Select the camera and let's add a built-in script. Click on the built-in checkbox to make the script be saved inside of the scene. This can have some disadvantages, so this is something I invite you to use sparingly, but let's do that. So create the script for the camera, save so that it gets saved in the game scene, as you can see in the left column here. I'm going to close the other tabs. And the thing we can do is in our physics process for the camera, because it's not a physics object, we are going to get the player node. So the player is going to be the result of a get node call. We're going to go up one step. So we go up to the game node and back down to the player. I don't recommend doing that in general, but when you are coding a quick prototype or you have temporary scripts, just do anything you want as long as it works, it's fine. And we're going to use the lookAt function that is going to rotate the camera to look at the target. So the target is going to be the player's global transforms origin. This is the location of the character in the world, and we need to specify the up vector, which is going to be vector3.up. With that, if you play the game, you're going to see that as you move the character, the camera will now look at it, giving you a nice little old school camera follow effect. You'll note one thing as well, it's that when you go behind the camera, the controls get a bit hard to use because right now they are absolute and not relative to the camera. This is something we will see in the third chapter of the course dedicated to the camera rig. But for now, we're going to move forward and add some animations because it's really lacking at the moment. See you in the next video for that.